you. I would love to introduce Bill McKinley from Keysight Technologies, who will give us an insight into advances in C-V2X and 5G testing. Bill and I participated in a webinar yesterday, and so I've seen a few of these slides before, and I know that that he just has excellent content. Bill has been with Keysight and a member of OmniAir for a number of years, and just joined our board of directors in December. So very excited to have Bill and his leadership helping to guide the organization. Mr. McKinley, I believe we are going to turn the screen over to you for you to share your slides.
Yep. Yeah, if you can. All right, let me do this and share my screen. Share it. And hopefully you can see that. Okay, so yeah, thanks for the opportunity here, and hello everyone. I thought I'd start with explaining a little bit about Keysight. I can't see any show of hands, but I have to admit I spend a lot of my time just explaining who Keysight are, and especially in the automotive world, where even though I think we're doing nice work in terms of making ourselves visible in OmniAir and 5G and other organizations, people still come up to me so often and go, "What do you guys do again?" So I thought I would give a little bit of an introduction here into, if I can move it on. So the thing about Keysight is that we're actually, our genes, our genetic makeup is from Hewlett-Packard back in the day. So HP was founded by Bill and Dave, who many of you maybe know, depending how old you are. And I started my career with HP because HP eventually came over the pond to the UK, and they actually founded a factory, as you called it then, just outside Edinburgh, where I lived, and it was developed test equipment from design, R&D, marketing, and manufacturing, and I was involved in the very well, not quite when it was started, but close to it. And so so we're basically HP now. HP started back in 1937, as it says here. But it kind of got mainstream, as I mentioned to Jason the other day, and he asked me to make sure I present this. In 1939, HP's first instrument was a audio oscillator. You can see it right there, using innovative resistance capacity feedback loops to actually, well, having variable resistance for variable amplifiers and variable performance was quite breakthrough in those days, and used an incandescent light bulb to get the variable resistance. However, a big customer in those days that got things going was Walt Disney. And indeed, it was for the movie Fantasia. And it was to enable so-called groundbreaking multi-channel surround sound. So that they needed this oscillator to lock the different channels, and that was what really got the revenue flowing with HP. So it's a kind of cute story back in the day. But HP went from 39 to 1998, and then it split because HP grew so big in terms of computers. Everybody knows HP now for laptops and printers and so on. So, but it started with instrumentation, and then it was decided that, well, instrumentation needed automation, and HP developed instrument controllers, as it was in those days, which grew and grew into computers and then PCs, and then that just took off. And then, relatively speaking, the instrumentation side got smaller and smaller. So it was decided to split that off. So in 1999, it was the creation. So it was a spin-off called Agilent Technologies. So I had another name badge, another business card called Agilent Technologies, and I won't go through a lot of detail, but that grew and grew. But then Agilent decided to get into life sciences and genetic and genomics, and again, the instrumentation side became a smaller and smaller part of that. And so in 2014, another split happened. So here's my third business card, even though I've had the same company, basically. Keysight Technologies was born. So we're back to kind of almost the Bill and Dave era. We're focused on test equipment solutions. So we're kind of back to the beginning in a sense. So a little bit about HP, just quickly. We're a $5.5 billion revenue company. We've got about 30,000 customers. We believe we're number one market position. Of course, we would say that, but I think we're a big player. 15,000 employees, 31 billion market cap, as was whenever the slide was done, and we have 20 R&D sites around the world. So we're relatively large in the test equipment solutions business. And the industries that we serve are, biggest one probably is commercial communications. We've been 2G, 3G, 4G, 5G, and we're pretty dominant in the 5G world. Aerospace and defense is a big business for us too. Where I live, my domain is automotive and energy. We call it industry solutions team. This is a business unit. I'll come to that in a second. And the other parts are semiconductors and what we call general electronics. But to go back to the automotive world, where we are all, I'm just checking my time here, Jason. So I'm in the automotive industry or business team, and we have what we call customer centers around the world. We have a customer center in Detroit, Novi actually, in Böblingen in Germany, Nagoya in Japan, and Shanghai in China. So we've got these customer centers that we can bring customers in, do some demonstrations. We have facilities there for customer training and so on. So we're pretty spread around the world. We focus on EV and AV. So AV being autonomous vehicles, so we call it an EV, electric vehicles, so the drivetrain stuff. And we'll come to some of our solutions momentarily, but CV2X is kind of where I've been working on the last few years. But not just that, 2G, 3G, 4G, 5G, e-call, emergency call, and other aspects of RF communication in the automotive world. But we also have automotive Ethernet solutions, a big battery test solutions and charging solutions. So we have a lot of solutions focused on the automotive industry. And we're focused on accelerating the journey to the future state of travel and transportation. So quickly, what we do, a big overview, won't spend too much time on this part because it's really not, because our business unit is split into two, as I mentioned. This is the EV side, but essentially we have solutions that focus on the grid side of the charging infrastructure. So we have devices that can test grid. We have solar panel emulators, so we can test for renewables, the charging stations themselves, the wall socket installations. To the in-vehicle stuff, the battery pack will test the charging setup, the longevity of the battery as we load them up, the inverters and so on, and also the batteries themselves, the battery forming, and the manufacturing side. In terms of AV or ADAS, there's, of course, you guys know there's many components into the vehicle these days. The vehicle is heading towards being more software defined rather than hardware defined. Many ECUs, all connected via Ethernet. So we play in touching all of this stuff in various aspects, including infotainment and V2X, of course, and radar, Bluetooth, Wi-Fi, ultra wideband testing technologies as well. And then finally, cybersecurity is becoming a bigger part of the industry, and we've got solutions that touch on the various attack vectors that are prevalent in the modern vehicle, and covering all these attack points, I suppose, or vulnerabilities that people want to harden. So all these technologies we can stimulate and attack and try to get access to the insides of the vehicle for nefarious activities. But so we definitely focus on this, and it's a growing part of our business too. And then finally, we do a lot of work on the network side. It's probably the biggest part of our business when it comes to communications. On the network side, we have a lot of capabilities now to test 5G, ORAN. Open RAN is the big buzzword, and MEC installations, cloud services. So we have got a lot of equipment both that are residing in the G-node Bs or the base stations on the network side, and in the backhaul to devices that we can roam around in and do drive test, or have backpacks and walking around to make sure that the user experience is as it should be. So we cover the whole telecom side quite thoroughly. And of course, the vehicles are connecting to the UU interface as well as MEC installations more and more. So we've got that covered in a big way as well. I'm going to spend the last 10 minutes or so just talking about what we've been doing in our business unit for autonomous vehicle testing and ADAS and V2X, CV2X in particular. And it's around this thing, what we call autonomous drive emulation, and all the aspects that brings. And this is a slide that my colleague Ken Horn, who many of you know, developed. Today, complexity of ADAS and AV functions that require just massive simulations. But ultimately, it's going to be done on the road. We need to do that, of course, but it's super expensive. It's not very repeatable when things go wrong, and it just takes a lot of time. And we just literally don't have the time to spend or drive millions of miles on railroads to try to get rid of all the issues and make things work. So there has to be some form of simulation and accelerated simulation. And so, but there's a gap in the middle that we see, and that's making repeatable tests under real world conditions with real sensors in a lab environment for repeatability. So if you look at what's going on in the world, the automotive industry follows this V model, and we've been adopting this, and you can see the components in the V model where we've got more or less traditional whole vehicle in the loop. Then if you go backwards, if you like, along the V, we have hardware in the loop, and then we have unit testing. But on the development side, design, model in the loop, and software in the loop are these components where a lot of the industry is trying to move away from hardware and railroad testing into simulations, model in the loop, and software in the loop for accelerated testing. And we're actually helping to drive that migration to the left, if you like. And we like to, we can simulate sensors, but we also can stimulate real sensors with real signals so that we can get real world results, I suppose. And we can simulate multiple real world scenarios with dozens of objects that can be thrown in front of radar sensors, for example. We can integrate with multiple platforms. I mean, ideally, it would be any hill system using any of the solutions that are out there and any 3D modeling software. And so the benefits are clear: less need for expensive road testing. We can validate these things earlier in the cycle and minimize integration costs. And this is our, I guess, the platform that we're developing or we have and evolving it. We call it the Drive Emulator, ADE, Autonomous Drive Emulator platform. And you can see, just as this kind of simplistic diagram, it's a kind of closed loop system where we've got some software modeling and communications control. We have the equipment that can simulate, so CV2X, 2G, 3G, 4G, 5G networks, ITSG5, DSRC, emergency call, but we also, of course, other sensors such as radar, LiDAR, camera systems that we could emulate and simulate. And all these things are stimulating the sensors on a vehicle, and sensor fusion, entities, decision making, perhaps AI, need to make the decisions and then control the actuators on the end vehicle. Now, if you do it in a lab, we can do all this stuff. We can feed the results back and then close the loop and do some interesting testing, such as stress testing, and throw various kind of curveballs at the system, see how it reacts. Now, just one slide on radar. We've just introduced a pretty innovative product we call the Radar Scene Emulator. And I've got a really nice video, but we didn't have time to show it today, and it just would take too much time. But this thing has been winning awards, and I just listed some of the awards that that this machine has been recently awarded, introduced last year, and it's innovative in that it blows away anything else that's in the markets, and you can kind of get a sense for what it looks like. This is in a chamber. It's the scale is hard to see, but it's in a sizable chamber, and each of these elements you see we call rixels. These are radar elements, and each of these rixels can essentially stimulate a radar under test, which is this thing here, and it can. Typically, radar testers are one or two mechanical targets that move around, but this is fully electronic. These rixels can be, you can imagine, up to 20 or more individual elements or targets, or it could be other vehicles, pedestrians, or whatever. And you can have them moving by just lighting up these rixels, like pixels on a TV screen, if you like. And it's testing radars to the depth that's never been done before. So this is innovative, and it's part of our ADE system. But more close to home, we've got our CV2X test equipment. This is our UXMB one box tester with a GNSS emulator. But this combination of components can test all the way from the physical layer of CV2X all the way through the protocol layers up to the application layer. And we use this in our so it's a certified test solution that Randy has certified, and in various certified test labs such as DECRA and TTA and others aboard our system, as well as OEMs and supply chain folks. And using the system, we can actually not only test the devices, but we can stress test, and we can simulate hundreds of other CV2X stations. So here we have some mapping applications. We can have it, and we have MCity. We've done demonstrations there where we can simulate the MCity track in software. We can have 2 or 3 stations come up, perform some scenario, but we cannot. By then, if that works, it's great. But then we can turn on 500, 700 other vehicles in the vicinity, all moving around. And so that really stresses a device. It may work perfectly well with 1 or 2 other vehicles in play, or a vulnerable road user or 2. But when you congest a channel with several hundred, things get really testy, and it really tests the performance in a kind of semi-real world situation. Okay, but we're part of OmniAir, we're 5GA, GCF. We've been around for a long time, and we're certainly one of the bigger players, and we believe that we're one of the most I suppose confident in our ability to test these signals to the design goals. We are compatible with our ITS stack to all the different regions in the world. Of course, the physical layer is common in the CV2X community. Here's a snapshot of our automated software packages, products that we sell into the test lab. So we run through all the test cases for the OmniAir certification. Now we acquired a company called Nordsys. They're part of the Keysight team now, and their portfolio, which is more predominantly field-based, we now have in our portfolio bag as well. So we have essentially sniffers, tablets to go and sniff air. I think this is one of the favorite instruments of Randy's. We have other devices such as Waveby Rod, which is an RSU type product. Waveby CarKit, which emulates an HMI on a device. We have a development platform as an OBU that OEMs can use to do some testing. So we feel we've got a pretty comprehensive suite of products that we're able to make some major contributions in this RF and the ADAS and autonomous vehicle space. Last couple of slides here. This came up at the board meeting where I was at, as Jason mentioned. I'm a new member of the board meeting, but there's an initiative in the industry about going back in this V model I mentioned from hardware in the loop, but now software in the loop or model in the loop. And we did some interesting work a little while ago where the path to automation in vehicles we're going to need a lot of stuff. There's going to be state-of-the-art realism, 3D engines, full motion video, dynamic sensor stimuli, stress testing, day one, day two use cases, and more, and then corner cases to make sure that we cover every eventuality. So we're in the middle of this. We take one example, such as EBL, which I think everybody knows. And so what we've done is we created the system where we have got this feedback loop I mentioned, this closed loop system. But there's a hardware in the loop path, but a software in the loop path. And so what we did was we thought it'd be interesting to see, compare testing and test results and time of test with hardware in the loop and software in the loop and separate them out. So first of all, we did software in the loop. So you can see the difference. We took out the modem. This is the OBU. And this side, we took out all the hardware and just had an interface into the software. So ITS, so we can send BSMs, for example, or CAN denim in Europe. So into the OBU, it parses the messages, it does some recognition, decision making, and then actuation. So we can do that in software only. And we do that by connecting up. You can see no hardware. This is just our software tool set connected via some either LAN or some other connection into the device, and we can do some testing. In this case, EBL. And so again, I have little videos, but no time to show it. But essentially, by doing software in the loop, you can test these KPIs. So we can look at the latency. Since the vehicle got the message, when did the HMI warning? And the software in the loop, you remember this number, 42 milliseconds. But also we can check for bugs, look at the performance, misaligned APIs, queue overflows, memory consumption, and stress testing. So we can do all of this stuff in software only. But then if you compare, okay, let's add hardware, because of course we're in the real world here. So we add back in the modem of the OBU. So then we have instruments that, RF signal stimulation, real GNSS into the OBU. And this is again, so we're adding our UXM product, the GNSS emulator, channel emulator, and then so we're going into RF here, into the same device, but now it's RF and not just software. We do the same KPI testing, and here we go with RF in play. So but this is not including GNSS lock time and getting the synchronization, but because of various other elements that are involved, if you remember back here, it was 42 milliseconds, but with hardware, it was almost a second, so 900 milliseconds. So hardware makes a big difference and takes more time. But of course, you can do other things with just hardware in the loop. But it's interesting comparison. A summary here, 80% of testing can be achieved with software in the loop by functionality, getting rid of defects, making sure there's APIs are aligned, making sure the performance is okay. And so that can save a lot of time doing software in the loop. Then, of course, you need hardware in the loop. You must add that to get the real world testing, which goes through other important elements. Ultimately, it'll all go in a vehicle and it will have to go on the real road for real world testing, but you can do a lot of testing before you get to that stage. Okay, finally, non-terrestrial network is getting a lot of attention in the industry. And just late, don't know if you saw this, or probably not, but Keysight, we just had this press release this came out on March 27th. So we were working with Qualcomm. We demonstrated first end-to-end 5G NTN network using these low Earth orbit satellites to have an end-to-end connection. So Keysight are already having some successes in this really far out capability. The automotive world, of course, for coverage, are looking at that pretty seriously. So we're well placed to take advantage of that too. Okay, 7 o'clock. Okay, whatever it is, and whatever time zone you're in, it's 7 o'clock my time. I think I've come to the end here. I'll hand it back to you, Jason. Thanks very much. Sorry it was so fast, but I'm happy to answer any questions offline.
That's okay. I appreciate the pace. I know we ran a little bit long as we were slow to get started, but thank you very much, Bill. Great overview. Hope you'd be willing to take a couple of questions. Maybe let me just kick it off and say, just in the few years that you've been doing V2X and C-V2X testing, how have you seen the testing world evolve? Is there are there areas of emphasis that maybe were less important a couple of years ago that are increasing importance? And if you're in the testing space? Are they doing validation testing or test laboratory? What are some of the major trends that you think people should be aware of?
Well, I mean, as you know, Jason, things started off with the DSRC or ITSG5 here in Europe, and so then there was the kind of pivot to CV2X, and it's taken a little while for that to get traction. There are a lot of trials going on, but I think what we're seeing is this move to more simulation, the recognition that just getting a car on the roads doing real world testing, while that's obviously important, that's really slow, very expensive, hard to replicate problems. So there's a pivot to simulating all these complicated day one use cases, day two use cases, these complicated scenarios that, you know, if something goes wrong, let's repeat that. It's hard, really hard to do that. Okay, let's go back again, get the pedestrian or the cyclist, do that again. And it then starts to rain, and all these kind of things is really problematic. So the move to simulation and looking at software, which is becoming a more and more important part of it, is really key. But the thing nowadays we're seeing is because of the kind of delay in PC5 direct communications, the network operators, they're seeing this as an opportunity to have CV2X messaging, so basic safety messages on run over the network, over the top.
Mm-hmm.
Of course, latency is involved, but then we have MEC playing a role. So yeah, it's an evolving picture, and you know, it's difficult to guess to see what kind of twists and turns might be in the future. But we're hoping, we are trying to keep our eyes on all the different scenarios or eventualities. So
It seems
it's
like we may be living
mixed picture.
with a blended world for a while, right? With a PC5 transmission, some legacy DSRC, and then also a MEC, and then some sensors at the infrastructure. Is that I mean, that's quite a challenge, I would imagine, for deployers. How about from the testing community?
It is, but it's a challenge we're willing to take on, you know, because it's all around safety and it's all around adding value to the industry to grow this business. So it's quite complicated to keep on top of everything. Of course, we have limited resources, so we have to make some calls. And I guess the other part of this, Jason, is cybersecurity. You know, it's becoming more and more an important part, and people trying to figure out how to make these how to harden these systems for you know, it could be nefarious activity, but it could just be rogue devices misbehaving and causing problems, and how do we negate that? So that's another trend that we're seeing as well.
Well, it's a
So,
little frightening for those of us who have to think about the attack surface just increasing as you have more vehicle connectivity. I'd like to open the floor to questions, see if anyone in the audience has any questions for Bill.
hello, Bill. This is Randy. I was wondering if Keysight had any initiatives going on applying bench simulation testing, which I definitely believe in the safety transportation world, for the overhead gantry RFID testing.
I'm not aware of that, Randy. It is something I was talking to one of the other board members about tolling. You know, and I was curious how the tolling industry is going to go, because these gantries, of course, they need updated and upkeeping and so on. It seemed to me that, you know, I don't know if this is where road usage charge is going, but having V2X tolling, you would then be able to pretty easily, I would have thought, put RSUs so that you can charge for usage and have the flexibility within the infrastructure. So I don't know if we have any simulation capability for RFIDs as we see them today, but if the industry ever moves to V2X tolling, then we could deploy our gear in that respect. So I don't know if that answers your question, Randy.
Yes, it does. Thank you very much. Greatly appreciated. I also sent a chat to everyone. The US DOT Summit registration email broadcasts just got posted. So if you're interested in attending, the email broadcast is out there. And if anybody doesn't have it, I could forward it to you.
Excellent. Thank you, Randy. Any other questions for Bill? Well, Bill, thank you so much again. And I know we're going to see you at PlugFest, and looking forward to seeing some of the Keysight demos there and some of the work and support of our members in testing. And just appreciate your remarks, and And I hope if folks want to get in contact with you, is there a, you put your contact information in the chat box?
I can do that. Yep, of course, I will do that. Yep. Well, no, thanks for the opportunity. It's a pleasure and enjoyed it. Yep.
Well, fantastic, sir. I really appreciate it. And